Welcome to the Sleepy Science Channel. Here, we use soothing sleepy bedtime science stories to unveil the tranquil mysteries of the universe for you tonight. Let's relax our minds and embark on a gentle journey into a world of science and dreams. Surrounded by the 430 Hz Earth frequency today, we embark on an epic journey. We will travel through the cosmos together, starting from our home, flying all the way to the end of space and time. Please fasten your seatbelts. Our journey is about to begin. This journey will span over 10 billion light years. This journey will look back over 10 billion years. I hope to use 50,000 words to outline a magnificent picture of the universe for you. For now, please forget the hustle and bustle outside your window. Let us turn our gaze to that deep night sky. Our story begins in a tiny corner. This corner is our home, Earth, in the vast universe. It is a rather ordinary planet, but for us, it is unique. It is the cradle of all life. Let us first feel the planet beneath our feet. Earth is a rocky planet. Its diameter is approximately 12,700 kilometers. This number sounds large, but on the cosmic scale, it is not even a speck of dust. Earth resides in a privileged location. This location we call the habitable zone. It is neither too close nor too far from the sun. This allows Earth's surface to maintain liquid water, and water is the source of life. Now, let's raise our perspective a bit. We will see that Earth is not alone in space. It has a close companion, that is the Moon. The Moon is Earth's only natural satellite. There are many interesting facts about the Moon. Its diameter is about 1/4 that of Earth. This ratio is very special within the solar system. Therefore, we sometimes call the Earth-Moon system a double planet system. The Moon's gravity pulls on Earth's oceans. Thus, we have the tides. The Moon always shows the same face towards Earth. Its far side, for a long time, was a mysterious world unknown to humanity until 1959. The Soviet Union's Luna 3 probe first photographed the far side of the Moon, leaving the Earth-Moon system. We officially enter interplanetary space. Our first neighbor we encounter is Venus. In ancient China, it was called the Teibai star. When it appears before dawn, we call it the morning star. When it appears after dusk, we call it the evening star. Venus is an extremely extreme planet. Its size and mass are similar to Earth's. Therefore, it is often called Earth's sister planet. But this sister has a rather harsh temperament. Its surface is shrouded in a thick carbon dioxide atmosphere, causing a strong greenhouse effect. The surface temperature of Venus is as high as 460 degrees Celsius, hot enough to melt lead and zinc. Its atmospheric pressure is over 90 times that of Earth. Furthermore, its sky rains sulfuric acid. Venus is a veritable hell. Farewell to the scorching Venus. We continue towards the center of the solar system. The next celestial body we meet is Mercury. Mercury is the smallest planet in the solar system and the closest planet to the Sun. Because it is so close to the Sun, Mercury's daytime side reaches temperatures of 430 degrees, while its night side, lacking an atmosphere for insulation, plummets to minus 180 degrees. The temperature difference between day and night exceeds 600 degrees. This is the most extreme temperature variation in the solar system. Mercury's surface is covered with craters, looking very similar to our moon. Its year is only 88 Earth days long, but its day is very long. One rotation takes 59 Earth days. Now let's change direction, leaving the inner rocky planets. We head to the outer reaches of the solar system. First, we will pass Mars. This red planet has captivated human attention since ancient times. Mars is red because its surface is covered with large amounts of iron oxide, commonly known as rust. Its atmosphere is very thin, composed mainly of carbon dioxide. Its surface features giant volcanoes, and deep canyons. The tallest mountain in the solar system is on Mars. It's called Olympus Mons, with a height exceeding 21,000 meters, more than twice the height of Mount Everest. The longest canyon in the solar system is also on Mars. It's called Valles Marineris, stretching over 4,000 kilometers. What fascinates us most are the possible traces of life on Mars. Scientists have discovered that water ice exists in Mars's polar ice caps. And even in ancient times, Mars's surface may have had vast oceans. Therefore, Mars has become the prime candidate for humanity's dream of extraterrestrial colonization. Flying past Mars, we are about to enter a whole new zone. Here, countless small bodies are scattered. This is the asteroid belt. It lies between the orbits of Mars and Jupiter. The asteroid belt is like the construction debris left over from the formation of the solar system. These bodies vary in size. The largest Ceres is now classified as a dwarf planet. Its diameter is about 950 kilometers, while most asteroids are as small as rocks. Although it sounds dense, the asteroid belt is actually very empty. Probes can easily pass through it without hitting anything. Occasionally, some asteroids, perturbed by gravity, deviate from their orbits and fly into the inner solar system. These are the near-Earth asteroids that could potentially impact Earth. Passing through the asteroid belt, a behemoth suddenly appears before us. It is the king of the planets in the solar system. Jupiter. Jupiter is a gas giant. Its size is beyond imagination. The mass of all the other planets combined, multiplied by 2.5, is barely equal to one Jupiter. Jupiter's most famous feature is the great red spot on its surface. That is a giant storm that has been raging for hundreds of years. Its scale could easily accommodate 2 or 3 Earths. Jupiter possesses a powerful magnetic field and a faint planetary ring. It is also a failed star because its interior is undergoing a degree of gravitational contraction and releasing heat. If its mass were several dozen times greater, perhaps it could ignite nuclear fusion, becoming another star. Jupiter is also a cosmic vacuum cleaner. Its immense gravity attracts many small bodies and comets that might otherwise enter the inner solar system. To some extent, it protects Earth from more frequent impacts, leaving Jupiter. We continue onward. The next stop is Saturn with its hat. Saturn is another gas giant. Its beauty is unparalleled. This is largely thanks to its spectacular planetary rings. Saturn's rings are not a solid sheet. They are composed of countless pieces of ice and rock. These fragments vary in size, from dust particles to the size of houses. They all orbit Saturn. In their respective paths. From a distance, they form a bright ring. Saturn itself is also very interesting. Its density is less than that of water. If one could find an ocean large enough and place Saturn in it, it would float like a ball on the water. Saturn also has a powerful magnetic field and numerous moons among Saturn's many moons. The most notable is Titan, Saturn's largest moon. Titan is the second largest moon in the solar system. It is even larger than Mercury. More remarkably, Titan has a thick atmosphere, primarily composed of nitrogen. Titan's surface has rivers, lakes, and seas, but what flows within them is not water, but liquid methane and ethane at extremely low temperatures. These hydrocarbons play a role similar to water on Earth. Therefore, scientists believe that life forms based on methane might exist on Titan. Flying past the magnificent Saturn, our journey truly begins to head towards the frontiers of the solar system. Next, we encounter two planets that challenge our understanding in another way. They are Uranus and Neptune. They are called ice giants. Uranus is a very peculiar planet. Its axis of rotation is almost lying down on its orbital plane, like a rolling ball. This leads to extremely dramatic seasonal changes. When one pole faces the sun continuously, the other pole is plunged into decades of prolonged night. Uranus's atmosphere contains methane. Methane absorbs the red wavelengths of sunlight, so it appears a pale blue-green color. It also has a ring system, but it is far fainter than Saturn's rings. And Neptune is the planet farthest from the sun in the solar system. Yes, I know, some friends here might mention Pluto. We will talk about it shortly. Neptune was predicted to exist in 1846 through mathematical calculations and then observed through a telescope. This demonstrates the great power of human reason. Neptune is a world of raging winds. It has the fastest winds in the solar system. Speeds can exceed 2,000 kilometers per hour. It is also a blue planet, but this blue is deeper than that of Uranus. Again, due to methane in its atmosphere. Now, it's time to talk about that controversial celestial body, Pluto. It was once the 9th planet of the solar system, but in 2006, the International Astronomical Union refined the term planet Pluto because it did not meet the new criterion of clearing the neighborhood around its orbit, was reclassified as a dwarf planet. This decision caused a huge stir at the time. Even today, many people feel it was treated unfairly, but science moves forward through constant revision. Pluto's world is far more complex than we imagine. It resides in the Kuiper Belt. This is a vast region beyond Neptune's orbit, composed of icy small bodies. In 2015, the New Horizons probe flew by Pluto, sending back unprecedented clear images. We discovered that Pluto is not a dead ice ball. Its surface has towering mountains of water ice, vast plains of nitrogen ice, and possibly even a liquid ocean hidden beneath its icy crust. Pluto also has an atmosphere, although very thin. It also has 5 known moons. The largest one is called Charon. Charon is very large relative to Pluto, so they are tidally locked to each other, forever rotating face to face, like a cosmic pas de deux flying past Pluto. We have not yet left the solar system. The sun's sphere of gravitational influence is far more extensive. The boundary of this sphere we call the heliopause. It's like a giant bubble encapsulating the solar system. Outside this bubble lies true interstellar space, and inside and outside this bubble there exist two theoretical spherical clouds. They are the Oort cloud and the Kuiper belt, which we just mentioned. The Kuiper belt is like a donut-shaped belt, distributed beyond Neptune's orbit. It is home to countless Plutos and smaller icy bodies. The Oort cloud is even more distant. It is thought to be a vast reservoir of comets, enveloping the entire solar system. The inner edge of the Oort cloud is about 0.03 light-years from the Sun, and its outer edge may extend up to 1 light-year away. Yes, 1 light-year. This means that light from the Sun, takes a full year to reach the boundary of the Oort cloud, and our solar system floats within such a gigantic cloud. When we occasionally see long-period comets coming from the distant depths of space, they likely originate from the Oort cloud. Perturbed by the gravity of passing stars, they embark on this journey lasting millions of years. Now, we finally step out of the solar system's gate. We are about to enter the vast space between stars. We call it interstellar space here. The unit of distance shifts from kilometers to light-years. 1 light-year is the distance light travels in a vacuum in 1 year. It is an unimaginable length, approximately 9.46 trillion kilometers. Our solar system's nearest neighbor, Proxima Centauri, is 4.2 light-years away. This means even if we traveled at the speed of light, it would take over 4 years to get there. And the speed of light is currently known to be the fastest speed in the universe. Proxima Centauri and its companions, Alpha Centauri and B, together form a triple star system. This is the Alpha Centauri system in many science fiction works. It is the primary target for human interstellar colonization. Now, let's look back and examine our sun carefully. The sun is the master of our celestial neighborhood. It is a star, a giant, hot ball of gas. Its interior, every moment, is undergoing intense nuclear fusion reactions. Hydrogen nuclei, under extremely high temperature and pressure, fuse into helium nuclei and release tremendous energy. This energy, in the form of light and heat, travels across space, illuminating and warming the entire solar system. The sun's mass accounts for 99.86% of the total mass of the solar system. It is the undisputed master. Its diameter is about 1.4 million kilometers. It could hold 1.3 million Earths. Inside the sun, the core temperature reaches 15 million degrees Celsius. From the sun's surface, enormous hot plasma is occasionally ejected. This is a coronal mass ejection. When these charged particles, following the interplanetary magnetic field, fly towards Earth, they collide with Earth's upper atmosphere, thereby producing brilliant auroras. Auroras are a cosmic symphony, played by the solar wind and Earth magnetic field. Those seen at the North Pole are called aurora borealis. Those seen at the South Pole are called aurora australis. They are like enormous colorful curtains, swaying gracefully in the night sky. The sun also has its life cycle. It is not eternal. It was born about 4.6 billion years ago, from the gravitational collapse of a primordial nebula. According to our calculations, the Sun is currently in its prime of life. Astronomers call this the main sequence stage. This stage will last for about another 5 billion years. When the hydrogen fuel in its core is exhausted, the Sun will enter its old age. It will begin to expand, becoming a red giant. At that time, its volume will become enormous. Mercury, Venus, and even Earth might be engulfed by it. Eventually, the expanded outer layers will gradually dissipate, leaving behind a hot core. This core will slowly cool, becoming a white dwarf, like a cosmic ember, slowly fading over immense time. And all the heavy elements that constitute our bodies, such as carbon, oxygen, and iron, come from stars that existed before the Sun. In their final stages of life, through supernova explosions, they scattered these elements into the universe. Therefore, each one of us, in a physical sense, is truly made of star stuff. Now, let's expand our view. From single stars to larger structures, countless stars, under the influence of gravity, gathered together, forming larger systems. These are galaxies, and the galaxy our solar system resides in is the Milky Way. On a clear summer night, when we look up at the starry sky, we can see a hazy band of light spanning the sky. That is the Milky Way. It is the view from within our galaxy. Looking towards the galactic plane, the Milky Way is a massive barred spiral galaxy. It contains between 200 and 400 billion stars. Its diameter is approximately 100,000 light years. This means that light takes 100,000 years to travel from one end of the Milky Way to the other. Our Sun is not at the center of the Milky Way. It is located on a spiral arm. This spiral arm is called the Orion Arm. The Sun is about 26,000 light years away from the galactic center. The center of the Milky Way is a very mysterious region. The stellar density there is extremely high, and it hides a massive secret, a celestial body of immense mass. It is Sagittarius asterisk, a supermassive black hole. The mass of this black hole is equivalent to 4 million suns. Although it does not emit light, through its gravitational effects on surrounding stars, we are certain of its existence. In 2019, the Event Horizon Telescope collaboration even released its photo, a ring of light surrounding a black shadow. In the Milky Way, besides single stars like the Sun, there are many binary star systems, even triple and quadruple star systems. For example, the Alpha Centauri system we mentioned earlier is a triple star system. Additionally, there are star clusters composed of young stars, like the Pleiades, also known as the Seven Sisters. In the winter night sky, we can see it with the naked eye, like a miniature Big Dipper. Between the stars, it is not empty. There exists extremely thin gas and dust. We call this the interstellar medium. Although these materials are sparse, they are the breeding grounds for new stars. When the interstellar medium gathers under gravity, forming giant molecular clouds, certain parts of the cloud become unstable, begin to contract, collapse, temperature and pressure continuously rise, finally igniting nuclear fusion. A new star is born. The same process also forms a rotating disk of gas and dust around it. Planets form within this disk. slowly coalescing. This is the birth process of our solar system as we understand it, leaving our familiar Milky Way. Let us continue deeper into the universe. Beyond the Milky Way lies the boundless space of the cosmos. There, countless island universes like the Milky Way are scattered. They are external galaxies. The first to confirm the existence of external galaxies was the American astronomer Edwin Hubble in 1924. He confirmed that the Andromeda Nebula, then thought to be a nebula, was actually a separate galaxy far beyond the Milky Way. This discovery completely changed humanity's view of the universe, making us realize that the Milky Way is not the entire universe. It is just an ordinary member within the cosmos. Galaxies come in various shapes, roughly divided into 3 types: elliptical galaxies, spiral galaxies, and irregular galaxies. Our Milky Way is a spiral galaxy, not, and the Andromeda Galaxy is also a spiral galaxy. It is the nearest large galaxy to us. The Andromeda Galaxy is about 2.5 million light-years away from us. It is moving towards us at a speed of 110 kilometers per second. In about 4 billion years, it will collide with our Milky Way and eventually merge into a larger galaxy, likely an elliptical galaxy. Please don't worry. Galactic collisions are entirely different from two stars colliding because the distances between stars are vast. During the galaxy merger process, the probability of stars directly colliding is extremely small, but gravity will violently perturb them, reshaping the entire structure of the galaxies. In the universe, galaxies do not exist in isolation. They gather into larger structures called galaxy clusters and superclusters. Our Milky Way and the Andromeda Galaxy, along with over 50 other galaxies, together form a small galaxy group called the local group. The scale of the local group is about 10 million light-years, and the local group belongs to an even larger structure called the Virgo supercluster. Its scale reaches 100 million light-years. Above the Virgo supercluster, there are even more immense structures, such as the Laniakea supercluster. In the Hawaiian language, Laniakea means immense heaven. Our Milky Way is located on one of the tendrils of this heaven. These enormous cosmic structures form an incredibly vast web. We call it the cosmic web. Galaxies are distributed along the filaments of this web, and between the filaments are vast, empty cosmic voids. Now, let us pause for a moment to ponder a more fundamental question. How did all of this begin? The answer to this question is the currently most widely accepted theory of cosmic origins, the Big Bang cosmological model. According to this model, our universe did not always exist. It was born approximately 13.8 billion years ago from an unimaginably dense and hot singularity. Then it began an expansion that continues to this day. In the first moments of the universe's birth, a series of incredible events occurred in an extremely short time. The universe underwent exponential, rapid inflation. This is called the inflationary epoch. Inflation smoothed out the wrinkles of the universe and also sowed the seeds for the later formation of galaxies. As the universe expanded and cooled, energy began to transform into matter. The most basic particles, like quarks and electrons began to form. Subsequently, quarks combined to form protons and neutrons. About 3 minutes after the universe's birth, atomic nuclei began to form. This process is called Big Bang nucleosynthesis. It primarily synthesized the lightest elements in the universe, hydrogen and helium, and trace amounts of lithium. Most of the hydrogen and helium in the universe today originated from that brief period. Thereafter, the universe entered a dark age because no stars had formed yet. The universe was filled with neutral hydrogen and helium gas. There were no light sources until about 400 million years later. The first stars and galaxies began to form. Their intense ultraviolet radiation ionized the surrounding neutral hydrogen. The universe became transparent again. This is called the epoch of reionization. The first generation of stars were typically very massive and very bright. Their lifespans were short. Within a few million years, they ended their lives in violent supernova explosions and scattered the synthesized heavy elements into the universe, providing the raw materials for the second, third generations of stars and the emergence of planets and life. So how do we know all this? How do we know the universe is expanding? How do we know the Big Bang happened? There are two key pieces of evidence. One is Hubble's redshift. The other is the cosmic microwave background radiation. Hubble's redshift was another great discovery by Edwin Hubble. He observed that distant galaxies are all moving away from us, and the farther away a galaxy is, the faster it is receding. This indicates that space itself is expanding. Like a balloon being inflated, the cosmic microwave background radiation is the smoking gun for the Big Bang theory. It is called the afterglow of the Big Bang. It is the first light left over. From about 380,000 years after the universe's birth, at that time the universe had cooled enough for electrons and atomic nuclei to combine into neutral atoms, allowing photons to travel freely through space. These photons, as the universe expanded, had their wavelengths continuously stretched, their energy lowered. Until today, they have become radiation in the microwave band, uniformly filling the entire universe, with a temperature of only 2.7 degrees above absolute zero. So, it's also called the 3K background radiation. In 1965, Arno Penzias and Robert Wilson accidentally discovered this omnipresent noise and won the Nobel Prize for it. Later, the COBE, WMAP, and Planck satellites conducted more precise measurements of this background radiation. It is like a cosmic baby picture imprinted with the universe's earliest secrets. However, the expansion of the universe is not constant as we initially thought. In 1998, two independent research teams, by observing distant Typea supernovae, reached a world-shaking conclusion. The universe's expansion is not slowing down, but accelerating. This means there is an unknown force counteracting gravity, pushing galaxies apart. We call this mysterious force causing the accelerated expansion dark energy. It is one of the biggest mysteries in modern cosmology. According to the latest measurements in the composition of matter and energy in our universe, the ordinary matter we can see The matter that makes up stars, planets, and us accounts for only about 4%. Another 26% is dark matter, and the remaining 70% is dark energy. Dark matter itself is a huge mystery. It does not emit, absorb, or reflect light. We cannot see it directly, but through its gravitational effects on galaxies and galaxy clusters, we are certain of its existence. It acts like an invisible scaffold, supporting the large-scale structure of the universe. So what will be the future of the universe? It depends on the nature of dark energy. The current mainstream view suggests that the strength of dark energy is constant. Then the universe will continue to accelerate its expansion. This means in the very distant future, our local group might merge into one giant elliptical galaxy, and all other galaxies outside our galaxy cluster will, due to the universe's accelerated expansion, accelerate away from us. Eventually, they will recede so far that the light they emit will never be able to reach us. The universe, for observers in our galaxy then, will become dark and lonely. All external galaxies will disappear from our view. This is the so-called heat death, of course. This is just one speculation based on our current knowledge about the nature of dark energy. We know almost nothing. It might evolve over time. It might lead to other, more extreme outcomes, such as the Big Rip. While exploring the universe, we always ask another question. Is life common in the universe? Are we alone? The answer to this question, we do not yet know, but we are searching hard. This field of science is called the search for extraterrestrial intelligence, or astrobiology. We primarily seek answers in two ways. One is directly searching for signs of extraterrestrial life, such as looking for fossils of ancient microbes on Mars or detecting possible life in the subsurface oceans of Enceladus or Europa. The other way is searching for Earth-like planets outside our solar system. These planets orbit other stars and might be within the habitable zone. We call them exoplanets. In 1995, Michel Mayor and Didier Queloz discovered the first exoplanet orbiting a Sun-like star, 51 Pegasi b. It is a hot Jupiter. Its discovery opened a new era in exoplanet research. Since then, we have discovered thousands of exoplanets using methods like the transit method and radial velocity method. We found that planetary systems are very common in the universe. Almost every star has its own planets. The Kepler Space Telescope further told us that rocky planets the size of Earth might number in the tens of billions in the Milky Way alone. Among them, a significant portion lie within their star's habitable zone. This greatly raises our hope of finding extraterrestrial life. Next-generation space telescopes, like the James Webb Space Telescope, will be able to analyze the atmospheric composition of these planets, searching for biosignatures such as oxygen, methane, which might be produced by biological activity. At the same time, we are also listening, using radio telescopes to scan the cosmos for possible non-natural radio signals. This is the SETI project. Although nothing has been found so far, this work continues because a definitive answer, whether yes or no, will profoundly change humanity's understanding of its place in the cosmos. Friends, our cosmic journey is nearing its end here. We started from the familiar Earth beneath our feet, flew past the 8 planets of the solar system, crossed the Kuiper Belt and the Oort cloud, entered interstellar space, browsed the magnificent spiral arms of the Milky Way, witnessed the collisions and mergers of galaxies, traced back to the beginning of the universe 13.8 billion years ago, and looked towards its distant and lonely future. Along the way, we saw the ingenious work of gravity. We saw the brilliant light of nuclear fusion. We saw the birth and evolution of the cosmos, and we saw the greatness and power of human reason, from Copernicus to Galileo, from Newton to Einstein, from Hubble to Hawking. It is through the efforts of generations that we, from a tiny planet, can glimpse the grand picture of the entire universe finally. I would like to end our journey today with a passage from astronomer Carl Sagan. This passage comes from Pale Blue Dot, that famous picture taken by the Voyager 1 probe from 6 billion kilometers away, looking back at Earth. Look again at that dot. That's here, that's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives, the aggregate of our joy and suffering. Thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. In the vast cosmic arena, Earth is a very small stage. But for us, it is everything. It is the only world known so far to harbor life. So, please cherish this land we temporarily inhabit. Cherish this pale blue dot in the immense darkness, because for the foreseeable future, this is all the world we have. Thank you for listening. May the starlight forever illuminate your curiosity. Until we meet again.